Hello, I'm Mr. Eulis, and welcome to AP Physics 1 online. I wanted to make an introductory video. I had one before that was just an introduction to the sum work, but clearly things have changed. I wanted to go over what the topics of physics are, a little bit of what to expect from what I can tell right now, and then what we are looking at doing for Unit 1. So, firstly, AP Physics. What is it, and what topics are we going to cover? So here are the basic list of topics. We're going to be looking at kinematics, which is basic motion, the velocity of an object, if that velocity changes, how long will it take to come to a stop, things like that. So it's just basic motion, generally known as kinematics. Projectile motion also fits into that topic as well. We have dynamics, which is basically forces, Newton's laws. Why do all those motions happen? So if you apply a force into something, how quickly will it accelerate? How long will it take to get to some position? And why is that happening effectively? We're going to look at energy, potential, and kinetic energy, transferring from one form to another, elastic energy, the energy of a rubber band. We'll look at momentum. So that's one of my favorite topics, actually, because you start to look at the collisions of objects and their interactions. So with that, you can make a lot of predictions of any sort of phenomenon. So a car crash, for example. If one car hits another, what are the forces like? What are the velocities like of these vehicles after a collision? Things like that. Circular and rotational motion, I have them joined together, although they're not always done together like that. Circular motion is things moving around in circles and orbits, for example. Rotational would be an object spinning around an axis, like a top. And so they are a little bit different, but obviously related. And so we're going to look at the forces keeping things together, the forces keeping things moving along a circular path, things like that. Waves and sound, light, all those things will be joined together within waves. Color, a little bit of color. And so what causes the interference of waves, things like that. And then lastly, we will effectively have electricity. So it'll be a little bit of electrostatics, so static electricity, but mostly we're going to be dealing with circuits. Basic circuits, mostly DC, one direction, direct current circuits. Basically a battery, a resistor, and a light bulb. What happens when you put two resistors together, one right after the other, versus if there's an alternate path, what happens to the resistance of the circuit as a whole, and what happens to the power consumption of the circuit. So that's what we'll be looking at there. So this is essentially the semester 1 replacement of a college physics course, an algebra-based college physics course. If you wanted to, if you feel like you are taking calculus this year, and you feel really confident in your calculus and your physics, you could elect to also take the calculus version of this test. Of course, you'd have to pay that extra money. I usually have a couple of students each year do that. And what that would do is that would allow them, if they pass that test as well, and usually the ones that decide to take it do pass it, they would then also have that course accounted for in college. So if you want to go into engineering, physics, architecture, things like that, that would be the course that you would need, and you could get that course taken care of at the college level. This gives you a very good fundamental foundation within the college realm. So if you do want to go into engineering, you do not need to worry about taking that calculus version of that class, at least not this year. When you go to college and go to take the calculus version of physics, you're just adding a little bit into what we've already done, and this will give you an excellent foundation. And virtually all of my students always come back and will tell me just how well prepared they were for that college calculus class. It was just a little bit of additional information, but they were right there for the foundation of it. As far as math goes, you should at least be concurrently taking pre-calc, if not having already taken it. And we're going to be using some basic algebra. It's just manipulating variables around, and you have to get a little bit more used to moving variables around. So something very simple, like we are going to deal with an equation of f equals ma, and you just need to be able to mentally prepare yourself to solve for a. So f over m. Oh my gosh, I need to get more used to using the pad, but it's just something that simple. And so you should then also recognize here that f, this terrible looking f that I have, is directly proportional to a. So if f increases, then a increases, which makes sense. This is force and that's acceleration. So you should recognize a direct proportionality there. M and a are inversely proportional. So if m decreases, then a would increase. M is mass. That should make sense. If you decrease the mass of an object and still push it just as hard, it will accelerate faster. So these are things that you should be able to pretty quickly recognize and manipulate a little bit to move along. Of course, it won't always be this simple, but you get the general idea. So now let's move along and go to this first unit. So here are the activities that I see happening so far. We have the intro video, which is what you're watching right now. And then you'll notice that here I have these modules labeled. And so what that is those are the modules that I had previously. Whenever I would do summer work in a normal environment, I had 5 modules to get you set up, hitting the school year ground running. And so that's what these are that I have already made. So we have the dimensional analysis video with a worksheet. That was module 1. I'm still going to give that out. So that video basically shows you how to manipulate variables a little bit. It shows you how to do some basic conversion, things like that. And it gets you kind of just started with some math intro. So there will be a worksheet there to practice some math and whatnot. And so we'll move along to the second thing, the second module that I'll be giving out, and I should probably get that posted today. That'll be the displacement and velocity video with a worksheet. So it's basically just basic motion stuff. Something's moving at a certain speed for a certain amount of time. How far did it go? Things like that. And so it's fairly rudimentary and just kind of getting your feet wet. Module 3, you're going to jump right into that as well. I have a video, instructional video on that, along with worksheet. Considering that something is accelerating at a constant rate, so it goes from 0 to 60, and it does that at a constant rate of change. How far did it go? What is its final velocity versus initial velocity? By the way, always be clear that you are differentiating between average velocity and an instantaneous velocity. So in that case of something going from 0 to 60, its average velocity is 30. It just is. If it was progressing to 60 at a constant rate, a little bit of a lie here, but essentially half the time it was below the 30, half the time it was above 30, on average it's 30. But instantaneous velocity, at the moment you hit the stopwatch, its instantaneous velocity was 0. At the moment that you hit the stopwatch again at the end, its instantaneous velocity was 60. And somewhere in between, for a moment in time, its velocity was 30. So that's instantaneous velocity. Always make sure you're differentiating between those two things, between average and instantaneous. So that will be unit or module 3 essentially is what it was. And so if you see any labeling that deals with module 3, that's what that is. Along with that, I'm going to have a reaction time lab. I think that's something that I've kind of rewritten a little bit. I think it's something you can work with at home. Typically, we have people working in partners with a meter stick. So one person drops a meter stick, and the tip of the meter stick goes right to your first finger and thumb. The first person drops the meter stick, and the second person catches it. Of course, you can't do it yourself like I just did, because I know that I'm about to drop it. So it needs to be actually measuring someone's reaction time, and you're measuring the reaction time by how far the thing goes, the stick goes, before you catch it. If you go so far to where you don't catch it, then, well, you're just slow. Hopefully you guys have some sort of ruler of some kind that you guys can use at home. It could simply be just a stick that you then, once it goes a certain distance, you then measure how far it was before you caught it. So you want to go from the tip of it to wherever your index finger and thumb were. That distance is where you would measure. And so perhaps you can have a sibling or a parent help you with that, and it should only take a few minutes to actually go through and do the measurements. If you can actually reverse it and have them do it as well, that would be excellent, and then you can kind of compare your reaction times. So then we have a reference frames video that I have not yet made, but I will. I'm working on some new software that I'm trying to work with before I make that video, because I want to be able to splice some things together. So I need some new video editing software. I need to play with that a little. The vector intro video, that's module 4. I have that made. It's ready to go. And that worksheet, which is a fairly straightforward worksheet actually. And let's see, we have the vector addition video with worksheet. That was module 5. That's just learning how to add vectors together. So just simply, if this pen here represents a vector, it just essentially is an arrow representing the direction that something is moving, the velocity of something as it's going, and the length of the vector, the length of the arrow matters. And so if something goes in this direction for 10 feet and then goes in this direction 10 feet, in the end it didn't really go anywhere, and that's the most simple example I can give you. I typically have had a lab, one of our first labs of the year, that I would call the Pirate Treasure Hunt Lab, R. And so typically I would have students go out and having to add together vectors, basically saying that the pirate had gone 10 meters, 30 degrees southeast, and then he went, 5 meters directly due west from there, and so on, adding the vectors up and finding the treasure that I would actually hide something in the grass out in the field. We of course can't do that now, but I think I do have an idea on how I can change that to make it a fairly interesting at-home lab. So let me work on that. Graphing motion video, which I do need to make, but that should be pretty straightforward, and I'll have to make the worksheet to go along with that. Gravity, it's the law, so obey it. And that's a video that I will be making coming up here. And then again, I'll make a projectile motion video. And I usually have a few demos that I would do in the classroom. So I'm going to have to work on recording those demos for you guys. And the projectile motion lab is usually a lab where we actually have these projectile launchers and shoot them in the classroom. So I will figure out something that I can do to replace that hopefully will capture your attention as best as I can. And I think we're almost done with that Unit 1, and the last thing is the Unit 1 homework. So in the textbook, there's homework problems that will be due before the unit test. And so usually the way I would do it is the homework would be due a few days before the test. We'll see if I change that up. I might have to in this case. But at least for now, let's just assume that the homework is due towards the end of the unit. When exactly that will happen, I haven't made my year schedule yet because things are moving and changing rapidly. So give me a little bit of time to get that figured out and to give you an exact time frame as to when things will be due. But you guys will be able to pick up textbooks from the school. I will arrange that. And in the meantime, what I can do is I believe I do have a PDF of the textbook, and I can send that to you guys so that you guys can start looking at some of those problems. So what is the expectation in terms of getting things done for summer work versus during the school year, when the school year starts? And that, I think, is just going to blend together in this class. So right now, I think I'm going to have, of course, the intro posted, the dimensional analysis video, the displacement video, the constant acceleration video, and those worksheets. I'll have those things posted today. The reaction time lab, I think I will also have that posted probably today. So these first things here will be posted. And I would hope that you guys can get those things done before the school year starts. We still have another several, 2 weeks even, before the school year starts for you guys. So you'll have more than plenty of time to get those things done. I also do hope to get this reference frames video done, and I will have that posted, and then these other 2 modules. So at the very least, I would like to have all of these things done in the before the school year starts. If for some reason you aren't able to get those things done, I'll work with you. It's not a problem. But really, to be honest, it's probably less work than it seems like. And in the past, it's always been like 4 to 5 hours worth of work, of summer work. And so here, the things I'm asking you guys get done is probably about that 5 hours worth, give or take. A lot of people get it done sooner. These other things we will get done as the school year progresses. And so I'm not terribly concerned about what we get done as summer work versus the school year. So don't go freaking out about, oh, I don't have time to work on this stuff right now. If you have issues, contact me. We'll figure it out. We'll work. There are more important things in this world right now than getting your summer work done before the school year starts. So you let me know if you have issues. I'll work with you, and we will make the best of this year that we can. So I hope to at some point meet you guys in person. I hope that we'll be able to do some sort of synchronous video that we can, communicate, in real time. However, for the most part, this class, at least the way it seems with the way that the district wants things to be run, it sounds like it will be asynchronous, meaning that I will make videos, post work for you guys to get done, and then you guys can, of course, contact me with questions. But it is not an expectation, at least my understanding at this point in time, and things change quickly. It is not my understanding that it is an expectation that you guys all log in at a specific period of time, and that we all are in a Zoom meeting, for example, at the same time. I wish I could do that. I think that it would be better, but I think that because everybody has different schedules, I think that for the most part that is a difficult expectation to have. I probably will have, in fact, I know I will have meetings, Google Meet or Zoom, whatever I use. I will have meetings that I will put out there like, hey, how about you guys jump in at this time and let's talk about some things. And if you're not able to make that meeting, I'll record it. But it would be great if you guys can jump in the meetings and ask questions, and we have a little bit more of a traditional classroom environment. I know you guys might be really hesitant to do that because it's different and you don't want to be put on the spot to ask questions, but I promise you it will be a better learning environment if we can do that at least from time to time. It'll help me kind of pick out where you guys might be having issues, and then I can modify things as needed from there. So I hope that that's, sorry if it's a bit long-winded, but I hope that that's a little bit of a good intro for you guys to get an idea of what's happening and what we're looking for. And that's it. I hope to see you guys soon. Take care. Be safe.